Today we're going to talk about Stonehenge. Stonehenge is a very important part of our history, and its history goes back 5,000 years. 3,000 years before Christ was born, and then now 2,025 years afterwards. Basically, there's two phases to Stonehenge, and we're not going to go over there. There's plenty of articles and books on this that you can read. What we're doing is a hands-on teaching session using STEM techniques, and that here includes 3D printing and smart telescopes. We're in the backyard here where we do backyard light cruising, smart telescoping. So basically to the girls, take one. This is 3D printed, and again we use a bamboo 3D printer, and I can print right now 8 colors. So this is 3D printed in 2 colors, if not 3. And this is Stonehenge. Now, none of this design did we do. We do teach design with primarily Tinkercad, and on occasion we do use Fusion 360. But it's a lot better just to find somebody out there smarter than we are who will actually make the design for us. So Bamboo has got a Bamboo Lab has got a good following, and there's lots of people designing good stuff. Okay? So Stonehenge is large rocks as big as a house, if not bigger. Many of them, as many as 50 to 90, depending on how many they find, which ones are standing, which ones are falling over. So how they did that years ago, they're still puzzling on how to do it. So anyway, those are the rocks as they're standing, and they have crossovers on top of them that hold it up like a door is held up and so on. They're called lintels. And there's many of them that have fallen over. Now it's made in a very specific pattern. You can see the first pattern is a horseshoe. Okay? And actually within that horseshoe, there's a second horseshoe that you don't see here. But you do see a pattern set out there against astronomy. There's a river leading up to this area, and then they have what they call the avenue, which used to be for carts and so on to come up there. And then at one point there's a stone that leads into the area, and that's called the heel stone. So that's the one that gives you the direction where the sun's going to come up and shine through there. So the sun will come up in the east, and we'll have sunrise on July 21st on the summer solstice. The sun will come up, and it will shine through that heel and come right through the middle. So they'll have a line through there. Okay? That line will be compatible with latitude, longitude, and the astronomical derivatives. The latitude, longitude, or the right ascension declination, whatever, of the celestial sky. So, first of all, put it down. And the first thing you do when you go out in the backyard astronomy like this is you've got to know where north is. So it's easy. The sun's coming up. We know where the sun is now. We kind of know where it came up. We know where it's going to go down. So we pretty well know east from west. Now that doesn't mean exactly east or exactly west. So today you can do that with your cell phone, or you can do it with a compass. There's different ways to do it. But your cell phone is the easiest way to do it. So you will set up, generally speaking, you must know north. You must know the polar star at night, okay, Polaris, and from then on, you know everything else from 0 around to 360. So you need some kind of compass. So the first thing, take these guys here. Take that one. Set it in the middle. Don't put that in there yet. So it said, this is a line here through here. So now you have to do with your compass, and you have to find north. It so happens this is my backyard, and I know where north is. So that is north there. So put that as 0. So now the key is the academic intellectual maneuvers that goes on is to know where the sun's going to come up next year, or where it came up 5,000 years ago. And we're doing that with a program called Stellarium. Both of the girls here kind of know what Stellarium is, how to use it, and so on. So you put in the date in Stellarium and it will give you the sky. And then you can go around just like we're going to do, and I'll put the other one on top of it. Okay? And let's go from east to west. So we know if that is north, 90 degrees is east. So that's east. So if you were at Stonehenge on Friday with 15,000 other people, okay, or if you watched it on television, okay, on the internet with 20,000 people, basically you would see the sun come up, and these people go there and they camp out. So they just go to have a party. Some of them are astronomers, some of them are academicians and so on, but they go to camp out. So they probably will interview some of the people there or so on. So now we know the sun's going to come up and where it's going to go through there. So it's going to come up and go this way here. Okay, so let's turn this around. Let's go this way now. Turn it like so. Now find north. Put 0 on north. Put 0 on north. Okay, now make the line go from east to west with the arrow pointing west. Now, if you were one of the lucky few that got in there, I'm sure lots of people did get in because this is Julie attended. This is our sun. This one, I printed the sun basically orange. Okay, make like a sun. So actually, this is a sun. Here, I'll give that to you. So this one I printed orange, but we can put lights inside. I'll talk to the young people here how to use LEDs. You put an LED inside there and light it up. So that one will print white. So that one, you can put a light in of whatever color you want. So now, put it where the sun will come up. In the east. Go ahead. Come up in the east. That's the sun, that's the sun. Just a matter from 3D printing. This one is very cleverly done. And we got this off Bamboo Lab Maker. It's got a nice screw on there, and so that's not easy to do. Before I build my bubble, I can print them, but I'm not sure I can get the right sizing done for both parts. So, okay, now let's move it over a little bit. Okay. I need another moon. What's that? Now, where is the moon going to go down? Where's the moon going to go? So these people were there at Stonehenge to see the sun come up and then the sun set. This will always happen on June 24th. When the sun is the highest in the sky, it's at the epitome. Okay? So that's the start of summer, the longest day of the year. The next time is December 21st. On the winter solstice, when it's at the bottom. So one of these, it only follows a certain path. One of them is called the Tropic of Cancer, and one is called the Tropic of Capricorn. Get those words in your head. The sun only goes up so far. If I remember right, that's about 27 degrees latitude. We're in Texas, so we're at about 30-some degrees latitude. So the sun is a little bit below us when it's highest in the sky. So now let's talk about the sun. We just had a solar eclipse. Thousands of people in the United States were involved with it. Let's take the white sun. Pick up the white sun. Most of you do not know the sun has topography on it just like the earth, just like the moon. Topography means landmarks, areas there. So if you look at the black areas on there, show it to you. Those are called sunspots. Those are very, very important to us. The sun can affect our radio waves. The sun can burn your skin. Okay, the ultraviolet light from the sun. So those black spots and the sun, they don't give them names. They're numbered. So if a new sunspot comes up, it's given a number. And then it's studied. There's people that just sit around studying the sun, and they will say that on the next 2 months there's going to be a sunspot. It's going to erupt, and that's going to send rays down to the earth that will affect our radio waves, that means airplanes, our satellites, our TV, and so on. So we pretty well know when that's coming. So, and the moon, I'll put the sun down, pick up the moon. Now these are lithophanes. These are made by some very bright person. Don't know where he's at in the world, but they're lithophanes, which means when you put a light in there, again, you're going to see them. So you'll see all the Marias, the seas. Okay, you're going to see all the different spots in the moon that you should know by now. There's about 5 craters at least you should know from the last year of watching people land on the moon. We had 2 spaceships land on the south pole of the moon. So where would the south pole of the moon be? Down at the bottom. That's the north pole. Cold, cold, cold. It's like on the earth. And then you have the equator, okay? And as you come up, you have the latitude and longitude, just like on the earth and just like the moon map that you worked with before. Just imagine that of interest, the moon map, Ayla, that you worked on with Elisa, 50,000 people have looked at it in 2 weeks. That means the lectures that you're getting here, 50,000 people listen to that, watch that video with the moon map. So we're getting ready for Moon Village Day on July 20th. And again, there will people all around the world be involved with that particular weekend. So if you put a light in there, an LED, as it says, you can use it as a room light, for a night light, or whatever. If you want camping, you put it in a tent. So put a coin, we'll show you talking how to put a coin, a little holder, and an LED in it, and that coin light will say, keep the LED lit for probably around 12 hours or longer. So it can be used as a night light, it can be used as a camping light, and it can be used out at night to look for things on the moon along with still area.